When you hear Elon Musk's name, most people think of rockets, electric cars, or AI somewhere in the cloud. But these aren't isolated projects, they're all connected pieces of a broader vision, carefully built step by step. Tesla didn't just make electric cars. Desirable light shifted the way the world thinks about transportation. Ads went from niche curiosities to inevitable reality, not because of trends, but because of psychology, infrastructure, and software-driven improvement. That same principle now applies to humanoid robotics with Optimus. Optimus isn't a showpiece waving at conferences. It's designed to operate where humans already work: factories, warehouses, and environments not built for machines. Tesla's real edge isn't just engineering. It's manufacturing discipline. They already know how to mass-produce complex systems reliably, and that expertise is now being applied to humanoid robots. Scaling is the real challenge, and Tesla is ahead. Hardware alone isn't enough. Machines need perception and intelligence. Tesla's full self-driving system isn't just for cars, it trains robots to understand and survive in human spaces. Every mile driven feeds AI models that predict human behavior, handle edge cases, and navigate unstructured environments. This intelligence powers Optimus and will extend to other robots across Tesla's ecosystem. Beyond Tesla, initiatives like XAI and Grok are about scaling intelligence itself. Hundreds of thousands of Optimus are trained in systems capable of reasoning about the physical world, not just generating text. This intelligence layer underpins robotics, space exploration, and long-term plans like Mars colonization. SpaceX, Starship, and Starlink aren't separate, they form the infrastructure for a connected, automated future. Humans aren't left behind. Neuralink aims to keep humans relevant in a world where AI and robotics are evolving rapidly. Direct brain-computer interfaces will allow faster interaction with machines, restore lost abilities, and integrate humans into AI systems in ways that were previously unimaginable. Robots are entering public life faster than expected. In China, Unitree's G1 humanoids performed acrobatic flips on stage, live, in front of thousands. These weren't lab demos, they were real, fully autonomous performances. Robots are no longer just tools, they participate in culture, entertainment, and public spaces, normalizing humanoid presence in society. This trend isn't isolated. Boston Dynamics Atlas moves with a single brain controlling all its body, performing gymnastic motions, cartwheels, and adaptive tasks in real time. Tesla's Optimus is scaling to millions per year at $20,000 each, using real-world AI to navigate and interact naturally with human environments. Consumer robots like 1X Neo are bringing humanoids into homes. Neo learns through real-world interactions and expert teleoperation, teaching users how to guide AI safely. These robots highlight critical future skills: spatial reasoning, privacy-first thinking, human-machine collaboration, and understanding AI behavior in real contexts. The takeaway is clear: robots are no longer invisible tools, they are collaborators, performers, and part of society. From factory floors to concert stages, from cultural events to theme parks, robotics is evolving in plain sight, accelerating faster than most imagine. The question is no longer whether robots will enter human space sites, how quickly society adapts to seeing them everywhere.